Hey Curie Physics students, this is Mr. Crone here again to help you out with the data collection for our Conservation of Energy formal lab report. Not a lot of data. It's actually a very small amount of data that we need to collect, but I have everything set up right here. So I just wanted to show you my face in the video for just a second. And now I'm going to turn you so that you can see all of our equipment and see exactly how we have this experiment set up. Let me just adjust the camera a bit here. All right, so one of the easiest ways that we can see conservation of energy in action is through a pendulum. And this would be very similar to if you were swinging on a swing. You give yourself some potential energy, somebody pushes you or they pull you up to a higher height, and then they let you go, and you convert that potential energy into kinetic energy. So the pendulum is a great example of an object that goes back and forth between kinetic energy maximum, which is here at the bottom where it travels the fastest, to potential energy. When this guy swings all the way up to here and comes to a stop, all that kinetic energy has converted back into potential energy. It comes to a stop, it's all potential, and then it moves back down through the bottom, and as it moves downward, it converts that potential energy into kinetic energy. And so if the law of conservation of energy is true, then what we should see is that if we measure the potential energy when it's all potential, and we measure the kinetic energy when it's all kinetic, those two should be equal to each other. So if I give this guy 7 joules worth of energy up here, when it passes through the lowest point, it should have 7 joules worth of kinetic energy. And we'll make both of those calculations, the kinetic energy 1/2 mv squared at the bottom, and the potential energy mgh at the top, and we'll compare those two to see if we get the same values, and we'll make a graph to show whether the energy was conserved. But because there's so little friction, there's so little places for the energy to be lost, generally speaking, this data should work out really nicely. Okay, so a couple of things that we would need to know. Obviously, if we're going to use the formulas for kinetic energy and potential energy, then we would have to know what the mass of this guy is. So I'm going to let this guy come down for a moment. I have a digital scale. Let me just let this guy settle, and then I'm going to write the mass on this piece of paper. I'm going to set it right here on this basket so that you'll be able to see it really clearly. So I'm going to put the whole thing on there. I'm not really concerned about the string. The string doesn't add very much mass to it. This says that it's 21.57 grams, so the mass would be 0.02157 kilograms. All right, so if you want to record that mass, the mass is 0.02157 kilograms, and I'll post that right here. Let's see if this guy will stick. Nope, doesn't look like it's going to stick. There we go. We'll just use a piece of tape then. All right, so if you didn't get the mass, there it is for you. That is our mass in kilograms. Now, one of the other things that we're going to have to do is we need to make sure that this thing is tied so that it's not going to hit this. So for example, if I leave it like this and we go like this, well, then it's going to hit this guy. So first thing that I'm going to do, move this out just a bit, is I'm going to pull this up until we get this at the right height so that I know that it can swing through without hitting the photo gate. Obviously, if it's the photo gate, we're going to lose some energy. That's going to be an outside force. It's going to interfere with our interaction here. All right, that looks pretty good. All right, so let's stop this and let's tie it at this point. Just tie it into a double knot. All right, let me just double check before I double the knot. All right, that looks good. Let's double up this knot. All right, get that string out of the way. All right, now this guy should swing. Let's just make sure. Yep, swings really nicely. Goes through the photo gate. Yep, no problems. All right, now, next step that we need to do is to make sure that we really are at the bottom, right? So we don't want to be getting a little bit to the side or here. I need this photo gate to be in the right spot. So I just want to make sure that this guy comes to a complete stop. Let me see if I can get him to stop moving entirely. And we'll figure out where the center spot is for this thing. So I want to make sure that the weights are right in the middle at their lowest point. And now, of course, I can't see the photo gate because it's upside down. So what we're going to use is a piece of tape. I'm going to put one piece of tape right here. This is going to help me to get my photo gate back in the same spot so that I'm consistently measuring the same way each time. Sorry, I used my piece of tape, so let me cut a new piece here. All right, so I'll make a little corner right here, and that way I just need to line up my photo gate in this corner the same way each time, and that's going to make sure that I get my photo gate always in the same spot. So I can pull the photo gate away, I'll be able to show you what the value is, and then I'll be able to take that photo gate and put it right back down and get it in the exact same spot. Okay, so we're ready to collect the information on the kinetic energy, but now for the potential energy. So the reason why I chose these washers is because I can see through the middle of them. So it's very easy for me to tell where the middle of the washer is. And because there's a hole in the middle of the washer, I will actually be able to see through to the ruler so that I can identify it. Now that's going to be impossible for you to see on the video. So I'm going to do that for you, and I'll let you know what height that I'm setting it to. Now, one thing to obviously make note of is that this thing is not at the 0 right now, right? The 0 is down here at the bottom. And in fact, actually, if you look at the ruler, you'll see that the 0 isn't even at the edge, actually. So there's probably about 1 millimeter or 2 on the end of the ruler. But there's no worries. It's no problem. So what I'm going to do is I'm going to measure the height of this guy when it's at the bottom. All right, and let me record what that number is. Sorry, I need to get my head down here where I can see a little bit more clearly. All right, so I would say that this looks to be about I would say about 3.6. Okay, now you don't need to record that. Don't record that. All right, now this is it's a little bit of a tricky thing, but it's not a super complicated thing. You can definitely understand this. So right now, this is at 3.6 centimeters. So let's say that I wanted to release it from, let's say I want to release it from 5 centimeters higher than that. Okay, well that's real easy because all I would do is add 5 centimeters to that. And so 5 plus 3.6 would take me to 8.6. And so what I'll do is I'll pull the ruler out here and I'll move this guy and I'll keep pulling this until I can see 8.6. And remember, that's not actually 8.6. Oops. So get this guy here and I'll look through, and when I see that I got it lined up at 8.6 and 8.6 is right in the middle, then I will let this thing go and it'll go through the photo gate and we'll pick up the velocity. So I will go in 5 centimeter increments. Okay, so you can go ahead and fill this into your table right now. Our first measurement will be at 0.5 because again, we're going to calculate energy, so we got to put this into meters. So our heights will be in meters 0.05, 0.10, 0.15, 0.20, and 0.25. Here, let me write this a little bit more clearly. 0.05, 0.10, 0.15, 0.20, and 0.25 will be our final height. All right, so that is information that you could go ahead and add right now to your data table. These will be our 5 heights, and I will adjust it. You don't need to worry about what I'm doing. I will adjust it by making sure that I add these heights to the fact that it's already 3.6 right now. That does not need to be in your table. Just these 5 guys need to be in your tables. All right, I believe we are ready to collect the data. Everything's tied up here. I can see everything pretty clearly. I'm going to try to move just a little bit so that I can see more clearly these heights. And I'm going to do my best to make sure that we can see this data. So I'll be bringing this up once we get the measurement. I'll hold it up. I will not read it off. Okay, so you can see there's a decimal in the middle there. It says 0.00. If I slide my finger through, then I find the velocity of my finger was 0.44 meters per second. So I'm going to do this 5 times. I'm going to bring this thing up. We're going to take a quick look at it, measure the velocity, and then I'm going to move on to the next height. All right. So let me set this so it's ready to go. I'm going to pull this guy out of the way. I'm going to line my photo gate up very carefully with the pieces of tape and make sure it's in the same spot. All right, and so our first measurement, again, is going to be at 0.5 meters. All right, let me see if I can get my head down there to see this clearly. All right, I would say that I am at 0.5. Oh my God, 0.05 meters. Here we go, guys. Ooh. And there was our velocity. So this is for a height of 0.05 meters. Here's our velocity. All right, now we're going to go to 0.1 meters. And reset my photo gate. Make sure this guy is lined up really good. And now we will be at 0.1 meters. Oh, well, that clearly did not work very well, but that happens all the time. Happens all the time. Scientists have to go back and recollect the data because it just didn't go well. It's difficult. If it was easy, we would have a world filled with scientists, but it's actually really difficult to collect good quality data. You really have to think carefully about how to make sure that this data is going to show whether this is true or not. All right, here we go. Second try. All right, I think that one got it. And here is our speed. Let's see if we can get that. There we go. All right, this is at 0.10 meters. All right, that was our second data point. Let's reset this guy. And let's go for our third height, which is going to be 0.15 meters. Make sure I get lined up really good. All right, looks like we're lined up pretty good. All right, that went really great. And here is that velocity. This is for 0.15 meters. For a height of 0.15 meters, this is our velocity. All right, let's reset that guy. We got two more. We're almost done, guys. All right, now we are going to 0.20 meters. And I can actually see this is going to be our last measurement because, make sure I got this guy lined up. All right, looks pretty good. Here we go. All right, I'm going to redo that one. Hold on, guys. I don't feel confident. We're only going to get 4 data points because I can see that this is not high enough for me to get to 25 centimeters. At least I don't believe I'll be able to. So let's just retry that again. I feel like I might have made a mistake there. All right, so we're going to, again, this is 0.20 meters. No, I guess that was about what I got last time. All right, this is our last measurement. We're just going to get these 4. 1.95 meters. And this was for a height of 0.20 meters. One more time. All right, so that is 4 data points. Unfortunately, it doesn't look like I'm going to be able to get to the 25 because I would need to... Oh, yeah, I don't think I'll be able to do it. Nope, this guy's not high enough for us to get up to that height. But no worries, that 4 data points should be more than enough. We have 4 different times where we tested to see if the potential turned into the kinetic, and then we'll make a graph of this thing to just show that, yes, not only does it work for an individual trial, but actually the pattern shows that it works for all of the different heights. All right, guys, good luck analyzing that data.